So this question gives you a rational expression. It's one polynomial divided by another polynomial, and asks you what are the excluded values for this expression. So what does it mean to exclude a value? Why would we need to exclude a value here? So the biggest thing that separates rational expressions from polynomials, the stuff that we spend all those modules 6, 7, and 8 looking at, is this division sign that's sitting right here. This completely changes the ballgame. Because as Nico was saying, there is one number in the universe that we are not permitted to divide by, and it is 0. The one number that we are not allowed to divide by is 0. So the reason we have to exclude values is we have to make sure that what we were dividing by, in other words, the denominator of this expression, is not permitted to equal 0. Cannot be 0. And that phrase gives away the tactic here for how to find these excluded values. What do I need to do? In order to make sure the denominator not be 0, what is that telling me to set up here?
So here's a better way of thinking about it. So what did we just do before? Literally, the question for the what was.
So we have the blueprint for this. As Nico was saying, the new insight that makes this a Module 9 question is that we need to know that what we're doing is making sure the denominator not be 0. But that leads us to an equation, which is a quadratic equation, which, according to what we learned in Modules 7 and 8, we know how to solve. We have a blueprint for it. We can factor it using a technique from Module 8, it turns out. And then once it's been factored, we can split it into 2 pieces, set each of the pieces equal to 0. That's a topic from 7C. Right? So it's old stuff just being used within a new context. And now to go back to the question about how to factor this, how did you decide this should be factored?
V plus 2 and then V minus 2.
And how did you get that?
Take 2 V's out of V squared and then take 2 out of -5.
Yeah, so this is, the reason that it's called a Module 8A topic is that it's kind of one of these special factoring forms. We have v squared, we have -4, but then we also want, when we FOIL this back out, typically when you FOIL something like this back out, you end up with 3 different terms, a v squared term, a v term, and then a constant term. But our v term has disappeared here. And so we need that to happen, and the only way it's going to happen is if the O and the I, when we FOIL this thing out, are equal and opposite. And that happens as long as the numbers that we're multiplying the v's by are equal and opposite, so that the outer terms and inner terms are 2v and minus 2v respectively, which when we add them together just go away. You can also see it as a difference of squares. After all, 4 is a perfect square. It's 2 squared. And we have a sort of what the book calls a special factoring technique. That anytime you see a difference of 2 perfect squares, you can factor it into the product of the sum times the difference of that which each of the terms is a square. So v squared minus 2 squared factors into v plus 2 times v minus 2. And once that factoring step is done, we have the green light on the other side of the equation, the 0 on the other side of the equation, to split this equation in 2, and then solve each of the resulting equations by respectively subtracting and adding 2. To find out that these are the 2 values of v which make v squared minus 4 equal to 0. And if v squared minus 4 is equal to 0, that means that this fraction has a problem. Right? We can't let a fraction's denominator equal 0 because then its value is undefined. So those are exactly the values that we need to exclude from consideration in this expression.